Good morning, my name is Christopher Galaska. Today I'm going to be reviewing a security analysis that was performed by my team and going over the recommendations that we have for NASA's future in cybersecurity. We'll do this by talking about the different security policies and how they impact NASA, the encryption standards that NASA uses as well as what's available. We'll talk about the findings of the security analysis that my team performed and what our recommendations are for improvements in NASA's cybersecurity program in the future. The first of the policies that we're going to talk about is the Federal Information System Management Act, or FISMA. FISMA sets the minimum standards of security for all agencies in the federal government. This is to say that agencies must adhere to the policies set forth in FISMA in order to remain operational. Now, FISMA is just a baseline policy. It should not be seen as the end-all be-all for all of our cybersecurity needs. It merely presents us with a baseline standard that is good for all federal organizations. Individual organizations should assess their own environments and create additional controls to make sure that their security policies fit with their organizational goals and provide sufficient security. In addition to FISMA, there is also NIST Special Publication 800 TAC 53A Revision 4. This document defines the security controls that should be implemented based on the objectives of specific organizations. If your organization has a need of security in an area of, say, personnel security, there is a section of this document which deals specifically with that. It tells you which entities should be responsible for which standards. It even has an appendix that lists all of the potential controls that you could put in place depending on the technology that you're using or the security goal of your organization. This document is a great resource for all security professionals whenever they're developing a cybersecurity plan or reassessing the security plan that's in place to ensure that it actually fits with the organizational goals and provides the right amount of security. So, in addition to just keeping up with the FISMA standards, all organizations must make sure that they take a look at NIST SP 853 to make sure that their stated security goals are met by their implemented security controls. In addition to the standards set forth by the NIST, the executive branch and the White House specifically has a vested interest in cybersecurity. The current administration understands the importance of cybersecurity, and they understand that the entire federal government is one entity when it comes to cybersecurity. An attack to one agency that is successful could have negative impacts across the entire federal government. For this reason, the White House has implemented a couple of presidential policy directives and an executive order that calls for the collaboration and information sharing between federal organizations. PPD1 states that all federal agencies must appoint a specific member to sit on an interagency policy committee. The purpose of this committee is to set forth a baseline cybersecurity policy that can be used across the federal government, as well as to share information about different cybersecurity threats or risks that they have discovered, different methods for mitigating specific risks, and just sharing information so that no one organization is hoarding a bunch of good information that other organizations would like to have. Presidential Policy Directive 21 extends this thought and gets federal agencies talking to the private industry, specifically focused on protecting privacy and civil liberties. This is directed at the information owners of critical infrastructure systems. So NASA, with all of the programs that they do and all the technologies that we develop here, has a big role in critical infrastructure systems. It's important that we have a good understanding of what all the other federal agencies are doing, and it's important that we understand what's going on in the private sector and how that impacts privacy and civil liberties. When it comes to encrypting our data, and that is to say data at rest, so data that's stored on different drives, whether that's cloud storage or on network attached storage or even on specific user machines, you have to have the information encrypted specifically if it is sensitive information. Now, there are different means of encrypting our information. The old standard that's no longer in use is DES, or Digital Encryption Standard. It was a 56-bit encryption key. It's been broken and is now obsolete. Basically, if you have enough processing power and a powerful enough computer, you can break DES. When it says 56-bit encryption key, what that's talking about is a binary system. So binary is a base 2 system. A 56-bit encryption system would have the strength of 56 bits of character. Since binary is a base 2 system, every single bit increase doubles the strength of the encryption key. So with that being said, if I had a 32-bit encryption key and I went to a 56, it would be much stronger. But a powerful enough computer can get through to the 56-bit encryption key. So the primary reason for a stronger encryption is the length of the encryption key. Now when DES was broken and it was no longer an effective standard, we went to triple DES or 3DES. What it does is runs the information through DES 3 times. It's more secure, but it's still not sufficient for our current environment. Somebody with a powerful enough computer and enough time on their hands could crack a triple DES encryption key. All they'd have to do is just run the algorithm until it breaks it, run it until it breaks it a second time, run it until it breaks it a third time. Now it takes a pretty powerful processor and a good amount of time, but it can still be broken. And so if it can be broken, it's not good enough for use in government information systems. So what we have now is the Advanced Encryption Standard. This is what we currently use at NASA. There are 3 different key lengths: 128 bits, 192, and 256-bit encryption. This key has not been broken. Currently, we don't have a processor powerful enough or enough time to break the encryption key that's 128 bits. As you can see, if you remember, I said that the bits are talking about a binary system, and every increase in a single bit increase is twice as strong as the one before it. So with DES, we had a 56-bit encryption key, and the minimum standard for AES is 128. That is exponentially stronger than the 56-bit encryption key. This provides sufficient encryption for a government information system. Now there are 3 different ways you can do it, just 128, 192, or 256. The downside of doing the stronger encryption, the 256-bit encryption, is that it requires more processing for our systems to be able to run the encryption algorithm. It's very strong. It's exponentially stronger than the 128-bit encryption, but at the current in the current computing environment, the 128-bit encryption key has never been broken. So NASA currently uses the 128 and the 192. Nobody's really using the 256 yet, but we recommend that NASA keep up with all of the NIST FIPS documentations, and if there is anything that comes out saying, hey, AES 128 is no good anymore, let's just use 192 and 256, to make sure that we're ready to migrate to the stronger encryption immediately if 128 or 192 becomes broken or obsolete. In addition to that, we need to make sure we monitor those same FIPS documents for any new encryption technology that could take the place of AES. As we move into the future and technology grows, and it grows at such a fast rate, we could see the day when AES 256 is not good enough. And so we just need to make sure that we are keeping up with what NIST is putting out there, and if another encryption standard comes along that is better, or if this encryption standard becomes obsolete, that we are ready to immediately roll to the new technology. Now here is our actual security analysis that we got into. We went into 3 specific families of controls in NASA's policies. Each of these families of controls has its own handbook that was published by NASA in 2011 detailing how the organization implements the controls for this family. The first one we're going to look at is identification and authentication. What we're talking about here is secure login for all of our users on any information system to which they've been granted access. In addition to that, we're looking at physical access controls for sensitive facilities. So who is allowed to use a card and swipe through a turnstile to go into a secure hangar? Who is allowed to show their ID card to a security guard and get on a secure facility? Who is allowed to use whatever authentication means are defined in this policy to log into specific information systems. In addition to that, this policy identifies the controls for the management of the authenticators. So we're talking about our common access card readers, talking about biometric devices, all of the things that hold the authentication information. We actually have to maintain the physical devices. In addition to that, NASA has to maintain the actual identification and authentication information that is stored in these devices, that's read by these devices. We have to have a secure way of storing user information so as not to present our users with a possible breach of their privacy. Next, we looked at personnel security. Personnel security takes a look at how to secure our information systems against our users from the time that they become a member of the organization until after they leave, whether it's voluntarily or whether they are terminated. The NIST special publication dictates that each position that's available has to have a risk designated for them. There's a process in here for hiring new personnel and security measures that should be implemented for contracted individuals. In addition to securing our information systems for all of our employees throughout their entire time, there's actually specific processes for what to do when an employee is terminated, which includes immediately taking away all of their access to facilities and information systems. Next, we had a look at security awareness and training, which is the big one for us because users present the biggest risk to any organization. You have to give users access to your systems, and in doing so, you create a risk. So training for all users is very important, and having specific training for personnel that have access to more sensitive information or personnel who are responsible for security is a must for successful implementation. We have determined two different ways to improve NASA's cybersecurity program. Updating the security handbooks that NASA's published, which haven't been updated since 2011, and making user awareness and training a priority. Like I said, most of the policies, most of the handbooks, were written in 2011 and have not been updated. An immediate update of all handbooks should be done to make sure that they are all in accordance with current technologies and they're actually applicable in today's working environment. In addition to this, NASA should adopt a policy of updating their security handbooks every 3 years. This means actually taking the ones that we have and redoing them completely and publishing a new one. Now, technology moves very quickly, and so there could be a time when there are urgent policy changes that need to be implemented right away. Obviously, we wouldn't do a new publishing of a security policy, which is our 3-year window, but we need to have the ability to update security policies on the fly, implement these new changes, and then just annotate them in the policy. A new change was made on this date in this year, and this is why we made it. This was the important flaw or the important threat or risk that we mitigated with this new security control. Here was a new technology that came up which started this new technology or this new policy that we're putting in place. Next is user awareness and training. Our current policy calls for annual training for all users and then additional training for anybody with additional rights or more sensitive information, so executives, for example, all of our network administrators and our security personnel. I propose that we increase the frequency to a semi-annual requirement and then create an even more specialized training for our high-risk personnel, so the executives, the security personnel, the network administrators. Individuals need to realize that security training is not just a check in the box, it's not just something that you have to do every year to get it out of the way, but it's actually a part of your overall responsibility when you work here. So reworking the security training policy and implementing a new policy, a strategic implementation of a new policy, would mitigate all of these threats. So in summary, we talked today about how policies dictate our requirements for cybersecurity, that NASA meets the minimum requirements, but we need to make sure that NASA gets going to get above the minimum requirement. Security changes quickly. We need to change our security policies to match. The security handbooks are out of date and should be updated. Users are our greatest risk, and awareness training should be prioritized to mitigate this risk. Thank you for your time.